All right, today's lesson is 16.2, mean absolute deviation. It's also known as standard deviation, and we're going to utilize the mean average strategy we've been working on, and we're going to focus on the following question: how can you determine and use the mean absolute deviation on a set of data points? All right, so let's take a look here at this set. This data represents the height in feet of various buildings, and so we're going to start by calculating the mean, which we've done. All right, so we're going to add all of our numbers together. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. All right, so once we get our sum, it's going to be very easy to divide. All right, it's always helpful to do that. And now you're just going to plug your numbers in. All right, so if you want to use a calculator, that's completely fine. 65 plus 62 plus 59 plus 56 plus 58. All right, so now I'm going to divide by 10, and I get 59.1. All right, so there it was at first, and again, very, very nice number to divide by because it's just moving the decimal over. All right, so we're going to have 59.1, and it says here, round to the nearest whole number, so it becomes 59. All right, so our skill now is called measures of variability. All right, so see how those numbers kind of go up and down from 59. We were talking about that the other day with your scores, how they go up and down. This is a statistic concept now. It's one that I actually didn't really use and learn until I was in college, and so you guys have a huge head start on me and then everybody else in my generation. So it's really nice thing that Go Math makes you look at that now. So you have to remember this number. I'm just going to go to the next slide here. If you're following along in the book, you could be going straight down, right? So this is what we're thinking of now, all right? So our mean is 59, all right? And now what we're going to do is we're going to measure how far away we are from the mean, all right? So what we're going to do is we're going to subtract our difference. All right, so this is absolutes now going up and down. All right, how far are we away? All right, so how far away is 59 from 60? It's 1. All right, so it's 1 here, and then just keep subtracting. All right, so that's all we're doing. All right, is we are putting down our differences. All right, so I'm just going back and forth. This one right here is exactly on point, so there's no variation there. Here's this. And here is this. All right, so notice how we're not putting the negative numbers if we were subtracting, 58 minus 59. All right, so it's just 1 away. That's all we're doing. All right, so now what we're going to do is we are going to calculate the mean of differentiation now. All right, the variances. All right, or deviation. There's that word. It's a good vocabulary word for you guys to use, especially in the 6th grade. To deviate from something means to kind of go away from something, to go away from a point. Sometimes you'll hear that people have plans and then they deviated from their plan. So it's a really, really good word. All right. So now what you're going to do is you are going to find the mean of all of your deviations here. All right. So you're going to add all of them up again. And I'm going to need a calculator for this one. All right. So I know my 10 already, right? Because of my 10 values. All right. So here we go. 2 plus 5, 7, 10, 14, 20, 23, 26, 27. All right, so again, I divide by 10, move that decimal point, and so my standard deviation is 2.7. And what that means is on an average now, the values of these buildings go up and down by 2.7. All right, that's how far they deviate on an average, right? And if you look at that now, that makes sense, right? Because there's a lot of 3s in there. All right, there's a 4, and then for the ones that are a little bit higher, there's ones that are a little bit less. And so our standard deviation here, or they call it MAD, is going to be 2.7 feet. All right, so that's all it basically is. It's just calculating the mean twice and knowing what this means, all right? And then you are going to subtract from one another. All right, so it's just important for you guys to understand the concept. All right, let's look at another one here. All right, so this is, a good pet world example that, sometimes families breed kittens. And so this is the amount of cats that the family is producing. And so what we do now is we find our average now for all these litters again. All right, so I'm going to find the average. This one works out really, really nice again. All right, so I have 10 there after I find my sum, so I can do this now without a calculator. We use friendly numbers, so that's 10. There's another 10, that's 20, plus 13 is 33, 41, 49, 49, 57, 57 plus 9 is 66. All right, so now I have 6.6. It told me to round to the nearest whole, so what I'm going to do is put 7. And now what I'm going to do is I'm going to find my deviation again. All right, so I am going to make like a little table right here underneath, and underneath these, I am just going to put now how far away each of these numbers are from 7. Not the greatest job there of making a table, is it, for me? All right, so here we go. That's 3 away. That's 2 away. 2, 1, 1. Right on point again. 1 away, 1 away, 1 away, 2 away. So let's find the average of all the deviations now. So here we go again. 5, 7, 8, 9, 10, 11, 12, 13, 14. All right, so there we go. Divide by 10, 1.4. All right, so it is close to 1. All right, so what you would probably do on this one is you'd use the decimal because you have 1-digit numbers there. But that's the whole idea. So you're finding 2 means for each, and then you are going to compare your deviations and find the average of that. All right, so again, your answers are going to be either submitted to me on Jamboard or on a worksheet. It's going to have this problem in it, which I think is a great application problem. So just take it, and you might be wondering, like, what in the world am I ever going to use this skill for in my life? Well, again, they use it when they're analyzing things. All right, I have a good bet that you guys are going to utilize this again in the future, especially in high school, and those of you guys who continue on to college. Hopefully, all of you guys in your college math classes or your business classes there. This is kind of a really good example here. All right, so teachers are being trained to standardize the scores they're giving to students' essays. All right, the same essay was scored by 10 different teachers at the beginning and end of their training. Okay, the results are shown. All right, so what you're going to do here for the first one is you are going to find now the average, the mean for the average score. And so when they say standardized is when people are grading your essay, they want to come up to make sure that there's not a huge range going up and down, a difference, between teacher to teacher. They want to make sure that the teachers are grading, consistently. And so now they're going to give training in between. And now you're going to then calculate the deviation again for the end of the teacher training. All right, so this question right here is going to make you realize or think, calculate, the standard, the MADs, the difference in deviations for both. Did they make progress in standardizing their scores? All right, so that's all going to be told by finding their mean for each of those and then finding the deviations in between. All right, so you're going to compare both of those numbers. I have it set up for you on your Jamboard or your worksheet. All right, so you're going to add those 10 together and then you divide. And then you're going to compare that number and this number. All right, another good application question here is what would it mean if the teachers had a MAD of 0? All right, what would that mean? All right, so think about it. All right. So another great final thought here for you guys to think about. Again, you guys are doing this every single day. It's calculating for you in option C. It's so your grades. That would be a good little practical assignment. If you go back over the last 10 days in Go Math or Google Classroom rather, what would your standard deviation be? So you would find your last 10 days of work and then you would average your scores together and what score out of 20 was your mean. And then what you would do then is you could look at your last 10 days and then you could calculate how far away were you from that score. All right, of course, the easiest way to do it is if somebody got a perfect score. We've had a couple students in here who have had 10-day stretches. I know one at least several times where the deviation would be 0 for that person because they got 20s on everything. All right, so it shows you again how great that student is doing. All right, so that's what we want for all of you guys is to be really, really consistent with your scores. Of course, it's okay to get one wrong. Never lose any sleep because you get one wrong on an assignment. But it just shows you the excellence that's been going on if people are constantly pumping out 20s after 20s. All right, so that's really, really great. So any questions, let me know. Again, you're just practicing the skill. You're going to do it on that Jamboard and then you are going to submit. Any questions, let me know.